today's lesson is Kirchhoff's laws, and in the Kirchhoff laws we will study the two basic laws. One is the Kirchhoff's voltage law and second is the Kirchhoff current law, right? So why we are studying the Kirchhoff's law? The Kirchhoff's law, they are helpful in studying or in solving the complex electrical circuits where we have more than two batteries and few resistances in a network. So it's very difficult if we have a complex circuit and how to find out the current in the circuit, different currents in different branches of the circuits. So by using this law, the Kirchhoff's law, it is very easy to understand, or it is very easy to find out the current flowing in different branches of the circuits. So the Kirchhoff's voltage law, that says that if we have a loop, in a closed loop, the sum of all the voltages across all the branches, right? Sum of all voltages, that should equal to 0, right? So we can write the voltage law like this also. Sum of all the voltages, right? By this, sum of all the voltages, that should equal to 0. Sum of all the voltages in all branches, right? In all branches of a network, you can say electric network or electric circuit of a network is also okay, of a network, right? So sum of voltages, that should equal to 0, right? And what about the Kirchhoff's current law? Kirchhoff's current law, that is equal to sum of all the current flowing across a junction or at a junction, that should equal to 0, right? So first of all, let me take the Kirchhoff current law, right? It's easy, very easy. So let me take an arrangement. We have this type of arrangement. So this is a junction, right? And we have three different resistors, right? Suppose this is the first resistor. Let me call this as R1. This is the second resistor, R2, and this is the third resistor, R. Okay? So assume I1 is flowing like this, I2 is flowing like this, and I1 and I2, they are meeting, they are approaching towards this junction. This is a junction. And suppose I3 is going like this, right? So I can make equation, sum of all the current, that should be equal to 0, right? Sum of all the current, that should equal to 0. So it means the current moving towards the junction, right, that will be taken as positive, right? So current moving toward the junction, that will be taken as positive. So I1 plus I2, and current moving away from the junction, that will be taken as negative, right? That will be taken as negative. So minus I3. And sum of all these current according to the Kirchhoff current law, that should equal to 0, right? Current going towards the junction, that is positive. Current moving away from the junction, that is negative. And sum of all the current, that must equal to 0. So this is Kirchhoff current law, right? Let us take one more arrangement, right? One more arrangement. We have a junction and few wires are connected to this common point, right? This is wire 1, wire 2, wire 3, wire 4, right? Suppose I1 is going away from 1, I2 is going towards the junction, I3 is again going towards the junction, and I4 is going away from the junction. Now apply the Kirchhoff law, and suppose this is 10 ampere and this is 2 ampere, right? And this is equal to 3 ampere and this is equal to 5 ampere, right? So these are the values of current. So apply Kirchhoff current law to solve this problem, right? So as per the Kirchhoff current law, the current going toward the junction, that is taken as positive, right? And current going away from the junction, that is taken as negative. So let me make the equation first, right? So because it is I1 is going, so minus I1, right? It is going away, plus I2 because I2 is going toward the junction, plus I3 is also going toward the junction, minus I4, and sum of all the current that should equal to 0. Sorry, I2 plus I3 that will be equal to I1 plus I4. Yeah, getting my point? We are making the equation. I2 plus I3, keep in the left side because they are positive, and take the minus I1 and minus I4 in the right side. So this is the equation, right? We are not solving for the current, we are just making the equation. So just ignore these values, right? No need to take this. Okay, so this is the equation. So sum of all the current that should equal to 0. Sum of all the current that is equal to 0. So I can write I2 plus I3 is equal to I1 plus I4. Okay. Now let us go to the Kirchhoff voltage law. Okay. So Kirchhoff voltage law that is helpful in solving the complex circuit having the more than one voltage source and multiple resistances. So let me take one of the situation. So suppose we have a battery, 6-volt battery, 6-volt battery. This is a 6-volt battery, and then we have a resistance, another resistance, and one more resistance. We have these 3 resistances, and each is of 2 ohm, 2 ohm, 2 ohm, 2 ohm. And we have one more battery, again 6-volt battery, and we have a resistance here, and this is also 2 ohm, and this battery is of 6 volt, right? So we have 2 batteries, each of 6 volt, and these resistances, each of 2 ohm, right? So how to solve, how to find out the current flowing in different branches? How to find out the current flowing in different branches, right? How much current is flowing here, how much current is flowing here. So we have to calculate the current flowing in each branch, right? So the Kirchhoff voltage law says that in a closed loop, sum of all the voltages that should equal to 0, right? So you see how many loop can be there? 2 loop, right? Upper loop, this one, and the lower loop, right? So first I will take the upper loop, right? And I will take the sum of voltages that equal to 0, right? Means some current will flow from 2 ohm, then there will be a voltage drop, right? Again, the sum of the current will flow from here, right? And sum of the voltage means the voltage from here plus voltage from here plus voltage from here plus voltage from here, that must equal to 0, right? The voltage drop here plus voltage drop here plus voltage drop plus this volt, that should equal to 0 in this upper loop, right? But there is a rule, right? There is a rule when the drop is positive, when the voltage is positive. What is the rule, right? So assume this is A, B, C, D, E, and F. Okay? So let me take the first upper loop, A, B, E, F. So take loop A, B, E, F. A, B, E, F. So it is a closed loop, right? A, B, E, F, and again A. Again A. Okay? A, B, E, F, A. It's a closed loop. We start from A and we end up at A. Right? Mika, clear? We start from A, B, E, F, and again. Right? So this is a closed loop. In this closed loop, I will start from A, right? Sorry, I will start from F. Okay? I will start from F like this, in the anti-clockwise direction, right? I will start from F and again I will go back to F, right? I will start from F and again I will go back to F. I will take the loop A, B, E, F, A, but I will start from F and again I will stop at F, okay? So when I start from F, right? When I start from F, so what happens? You see, I meet with the negative terminal of the battery, right? So I am moving from negative terminal to the positive terminal. It means I am moving from the lower potential to the higher potential, right? I am moving from lower potential to the higher potential because negative terminal has the low potential, positive terminal has the high potential. So I am moving from lower potential to higher potential. So it is a built up potential, means potential is increasing, okay? So what is the voltage here? So that is plus 6 volt, right? Clear? When I am moving from negative to positive, so it's a rise of potential. Rise of potential. Clear? Negative potential is a low potential, positive potential is a high potential, right? So the potential is increasing from negative to positive. So when potential is increasing, that is taken as plus. Suppose I move from A to F. Suppose I move from A to F. So I will move from positive to negative. That will be falling potential, right? When I'm moving from, or when something is moving, when some charge is moving from positive to negative, it is moving from higher potential to lower potential. So in that case, this will be minus 6. Clear? That will be minus 6. But here I am moving from negative to positive, so this is plus 6. Right? And then the current starts from here. Suppose the current is I. Suppose the current is I1. Okay? I1, right? Now the same I1 enter into this 2 ohm. Okay? And I am also moving from A to B now, right? Because I start from F and then to A. Now I am moving from A to B. Now I am moving in the direction of current, so the voltage drop that will be positive. I am moving in the direction of current. You see, the current is moving downward, I am also moving downward. So the voltage drop is 2I1, right? That will be positive, right? So this is plus 2I1, okay? Plus 2I1, because the direction of current is downward and I am also moving from A to B, because this is my loop. I will move from F to A and then from A to B, right? And I am following the direction of current, so the voltage drop 2 into I1, that will be positive, right? Yeah.
Is it 2 because of the...
The 2 is 2 ohm, is a resistor of 2 ohm, right? So what is voltage? Resistance multiply current. V is equal to I into R. So voltage drop across this resistor is I into R, right? So 2I1, okay? Because the Kirchhoff law says that the voltage, the sum of all the voltages across all the resistors, that must equal to 0. So I will take this plus this plus this plus this is equal to 0, right? So the voltage drop here is 2 times I1, okay? Now, current is coming from the lower battery also. Suppose this is I2. Because this is the first battery, this is the second battery, right? This is first battery E1, this is second battery E2. The current is coming from here. Now this I2 is coming, reaching at this junction. So as per the Kirchhoff current law, these two current, they will be added. So they will add I1 plus I2, right? They will add I1 plus I2. So at this point, the two current will be added and the two current I1 plus I2, they will start moving towards this 2 ohm, right? Means they will start moving from B to E. Okay? Okay, so at this junction, the current from the upper battery and the current from the lower battery, they meet, right? And they join together. So I1 from upside, I2 from downside. So I1 plus I2, now that start moving from B to E, right? Okay, so because I am moving in this loop, so when I move from B to E, now what is the voltage drop? What is the voltage drop? So it is 2 times I1 plus I2, I1 plus I2, L1, clear? Because voltage is current into resistance. Current is I1 plus I2 and resistance is 2 ohm. Okay, now again, now I reach to this point. Again when I reach to this point, the I1 will go up and I2 will go down because I1 has to go to its own battery. I2 has to go to its own battery, right? Because I1 starts from positive terminal, so again I1 has to reach to the negative terminal. Likewise, I2 starts from this lower battery from the positive terminal, and after completing the loop, the I2 again it will go back to the negative terminal, right? So from this point, again I1 and I2 they separated. So from these two junctions, we can say the current at the junction that follows conservation of energy, right? So you see at this point, the total energy is I1 plus I2. So again at this point, the total energy again, right? So that will be I1 plus I2, and I1 will go this side, I2 will go this side, because in this resistor of 2 ohm from B to E, there is no consumption of energy, right? So total energy at this junction, that must equal to total energy at this junction. So conservation of energy. So at all the junction in any network, energy remains conserved, right? Energy remains conserved in any electrical circuit at any junction. Okay, so now because I am moving in this loop, so what is the voltage drop across this? What is the voltage drop here? So voltage drop is plus 2 times I1, 2 times I1, and sum of the voltages that must equal to 0 as per Kirchhoff's voltage law, right? So again let me repeat it. I am using this upper loop, upper closed loop. I will start from F to A. So when I move from F to A, what I find, I encounter the negative terminal first, and then I encounter the positive terminal. So when I move from negative to positive, so that is a rise of potential, right? So it means plus 6, right? So this will be taken as plus 6, okay? And then I move from A to B. So the voltage is 2 into I1. So this is 2 into I1 because the current is I1. And then I move from B to E, so the voltage is 2 times I1 plus I2 because I1 is from the upper battery, I2 from the lower battery, they meet at this junction, right? And they combine together and they start moving from B to E, so 2 times I1 plus I2. And finally at this point, again the two current they will be separated, I1 will go up, I2 will go down. So the voltage drop here, that is 2 times I1 is equal to 0. So if I solve this, this is plus, so 6 plus 2I1. Now this is mathematics. 2I1 plus 2I2 plus 2I1 is equal to 0. Now check the I1. So this I1, 2I1, 4I1, and then 6I1, right? 6I1. So 6I1 plus how many I2? 2I2. 2I2, and this is 6 plus, right? 6 plus 6I1 plus 2I2, that is equal to 0. So let me take this as equation 1. So from the upper loop, I get equation 1. Likewise, from the lower loop, again, I will get one equation. So how to get? Now I will move from the lower loop, right? So that's our choice, right? You can move clockwise or anti-clockwise, that's your choice, right? Okay, so if I move in this loop, right? So from here to here, like suppose I move like this. So now I choose the loop B, C, D, E, B. So in loop B, C, D, E, B. Now we are moving again anti-clockwise. That's your choice. You can go clockwise also, right? So when I move from here, means now there is no resistor across this branch, so there is no voltage drop. So from B to C, there is no resistor, so there is no voltage drop. Okay, now I move from C to D. So when I move from C to D, so I move from higher potential to lower potential. So there is a fall of potential, right? From higher potential to lower potential, there is a fall of potential. And when there is a fall of potential, that will be treated as minus battery, minus voltage, right? When there is a fall of potential. So this will be treated as minus 6 volt. Clear? Minus 6. Now I reach to this 2 ohm. Now check the current flowing in the loop. So the current is moving like this, right? From D to C. But I am moving from C to D opposite to the current. So the voltage drop that will be negative. Clear? The voltage drop that will be negative. So how much voltage drop will be there? Minus 2I2. Minus 2I2. So minus 2I2. Okay. And again I move from D to E, there is no resistor, so no potential drop. And finally I move from E to B. When I move from E to B, so I am moving opposite to the current, right? Because the current is from B to E, right? And my direction is E to B, so again minus 2 times I1 plus I2, that should equal to 0. That should equal to 0. Okay, now we just solve it. Minus 6 minus 2 I2 minus 2 times I1 minus 2 times I2 is equal to 0. Okay, so check for I2. This is 2I2 and this is again 2I2. So minus 6 minus 4I2 minus 2I1, that is equal to 0. So take this as equation 2 and this is my equation number 1, right? So now just a matter of solving these equations, right? By solving these equations I can find out I1 and I2. So how to solve? I have to cancel either I1 or I2 from these two equations, right? So you see which parameter I can cancel. Check for 2I2, right? So this is 2I2 and this is 4I2. If I multiply this equation by 2, if I multiply equation 1 by 2, then I will be successful in cancelling I2, right? How I will do? So this will become 12. Again 12 I1 plus 2, sorry, this will become 4 now, okay? 2 to the 4, so 4I2, that will be equal to 0. Okay, so now I add this equation and this equation, right? So let me take this now as equation 3. So equation 2 plus 3, right? Equation 2 plus equation 3. So equation 2 plus equation 3, right? So equation 2 is, equation 12, equation 3, 12 plus 12 I1 plus 4I2 is equal to 0. And this is minus 6 minus 6 minus 4I2. Minus 4I2 means here minus 4I2, right? Minus 4I2. Clear? Minus 2I1. Minus 2I1. That is equal to 0. That is equal to 0. Just take the sum of these two. So now this minus 4I2, plus 4I2 and minus 4, that will be cancelled. So 12 minus 6, 6 plus this is 10 I1 is equal to 0. Right? So now this is plus 12, so plus 6 plus 10 I1 is equal to 0. So I can calculate I1, that will be equal to minus 6 by 10. Okay. So 10 I1 is equal to minus 6. So I1 will be equal to minus 6 upon 10. So that will be equal to 0.6 minus 0.6 ampere. That is my I1. And if I calculate for I2, put the value of I1 in equation 1 or 2, right? So where you will put minus 7.2, 12 minus 4.8. Okay, 4.8. So 4.8 plus 4I2 is equal to 0. So I2 will be equal to 4.8 by 4. So this will be my I2. Okay, stop.